Good afternoon, ladies and gentlemen of Precalculus. We're going to continue on chapter 2.4, and we're going to kind of put together some of the things we've been working on the last few days of class, from yesterday to Friday before the break to Thursday before the break. And so we're going to use the graph to guess possible linear factors of f of x, then complete the factor of f of x with aid of synthetic division. So what do we know about this function here, both from the graph and from the function? Pardon me?
The end one can be divided by 3. 3 times 17 is 51,
so that's a guess at 1. But so are you saying that's one of the factors?
3 and 17 are the only things that times each other to equal 51, besides 51 and 1.
So 3 and 17, and really, I'm glad Kayla mentioned that. So what we call these, this is something called the rational roots theorem, and we probably start on this tomorrow. And so Kayla, I'm just going to go ahead and write this. So Kayla's doing some advanced thinking. We're not going to talk about that in specifics today, but this is going to be for reference tomorrow, because that's where, if we have time, we'll get there tomorrow. If not, on Friday. Probably tomorrow. Okay, so that's one thing she noticed, those factors of 3 and 17. That's an important thing. Good job. What else? What else do you notice about this?
There's 3 roots.
Okay, so they're, okay, we'll say odd-natured. Now, it's not specifically odd, because why odd-natured and not odd?
I don't see the what line.
Yeah, odd would be if it actually does rotate about the origin, right? And this does not strictly rotate about the origin, but it is odd-natured. And what tells you that it's, two things will tell you it's odd-natured here. What?
Mean behavior.
And behavior. Starts low, ends high. Very good. What else tells you odd behavior? Third power. Okay? So those two things will tell you. So you have a graphical evidence and a function evidence. What else do we know about this thing? What have I been talking to the cheerleaders about? What have I been talking to the cheerleaders about? Odd, even, even, right? So this is odd what?
Odd positive.
Odd positive. So we know this is a positive function, both from, as Will mentioned, graphical evidence, because we see start low and end high, and because of the actual, we have 5x cubed, right? That's odd-natured, odd positive right there. Okay, now let's go to the graph right now, and it says guess possible linear factors. So it says use the graph. So what do we notice on the graph here?
The y-intercept is 51.
Okay, y-intercept is 51, which we know from the equation and the graph, right? But what do we notice along the x-axis?
The x-intercepts are negative 3, 1, and...
So x is equal to negative 3 is likely x-intercept, right? And doesn't that kind of match pretty well with what Kayla was saying? If you look at that, see, you can kind of put these things together if you're thinking. And then also x is equal to 1.
and 3.
And so what are going to be possible linear factors of this based on those zeros?
30.
So here's what we do here. We put x is equal to negative 3, and we solve this equation for 0. How do we solve that equation for 0?
Just move everything on one side, so it'd be x plus 3 equals 0.
Yeah, so we have x plus 3 is equal to 0. So that's going to be guessed on one possible linear factor, right?
And then the other one would be x minus 1.
So x minus 1 is equal to 0. So now we have x minus 1. And this one over here, well, it says use guess possible linear factors, and from everything we see, and even what Kayla told us here, that looks like that's pretty good. So it says use synthetic division. How do we use synthetic division to test, to completely factor with aid of synthetic division?
You set it up and work it.
Okay, how do we do that?
So you do a little bracket. And you put the 5, the -7, -49, and then 51. And then let's start with the 3 on the outside.
Put 3 out here?
Yeah. Move down 5. It'll be 15. It'll be 8. And that'll be 24. So that would be 25, -25. And that'd be 75. So that'd be -24.
Okay, so is that right?
No,
What's wrong?
it has a remainder not equal to 0.
Remainder not equal to 0. So what happened is Will set this up and he worked it out, but he noticed that something wasn't right, okay? And he noticed because we have a remainder here. So what went wrong here? Will, you can tell us, or anybody else, what went wrong? Something went wrong. What went wrong?
Why don't you tell us this time, Mr. G, we should need to help.
No, Kayla, you're enough of a genius to figure out that rational roots
I'm very far
theorem.
from a genius, Mr. G.
Well, I mean, relatively speaking, for the context of what we're looking at now, I'll just call you genius for sake of time. What is missing here? What is wrong?
Negative.
Negative what?
-1.
Negative 30.
What we do is we put the value of the 0 here, right? Because if this is a factor, then the value of k is going to be -3. So we're going to put the negative right out here. So what I'm going to do is, and I'm going to have Will just, okay, Will, now let's go ahead, Will.
All right, so we get 5, then a -15, and a -22, and that would be -66, or +66. So that'd be 17, and then that'd be 51, -51.
0. Okay. You notice that 17 sitting right here? Okay, what next?
So you just write it down.
What next? Okay, so next thing, we continue, right? So we have 5x squared minus 22x plus 17. And what goes out here? 1. So we bring this down, we get 5. It's 5 here,
17.
-17, and
Which equals 0.
Huh?
okay?
Yeah.
So what is our factor going to be here?
It is going to be the
5x minus 17. Okay, see, that's what Kayla got us earlier, right?
Not exactly that, but yeah.
Well, no, she said 3 and 17 would have to be involved somehow. And do you see that right here? The 3 and the 17? So anyway, this is going to be completely factored, and so this is going to be our answers. Now, what is the value of the 0 here? Because it looks like it's between, it's kind of between 3 and 4.
Yep.
So if we set 5x minus 17 equal to 0, what's our 0 going to be?
3.4.
Yeah, so we divide 17 by 5, we get x is equal to 3.4 if you decimalize it. And does that look about right?
Yep.
For a graph? Yeah, it does. Now, what I want you to do is go ahead and work on 26, and I'm going to pick on somebody for this, and I really do appreciate Will's help on this, and that was awesome, and also Emily picking up that -3. I appreciate you doing that.
Can you give us the next slide, please?
You don't have, oh, you have better graphics on this next one? Yeah, I got a little better graphics than you do. Now, I'm running out of these, stars. But I have Miss Van who is helping me out. She's ordering a lot of these, because these are all I have. Anybody know what happened to Angel?
He fell in one hole?
Oh, seriously?
Analyst said he had a family emergency. Really?
Yes, Will, you were pretty good with the rock trivia yesterday, leaving class. That was really pretty good. It reminds me of a joke that my cousin and I used to have like a long time ago, that there was a popular rock group out of Canada called the Guess Who. Like, who does this song? Guess Who? Same thing. Have you ever heard of that group, the Guess Who, from Canada?
I think so.
Mr. G,
Yes.
how do you know which infects and receptors start with?
All part. Okay. What did you say? That was a good question. What did you say? Go ahead. Say it again.
How do you know which infects and receptors start with?
Okay. Kaylee asked the question. How do you know which x-intercept to start with? Okay. Let me go ahead. I'm going to go back here and try to answer this question, or let somebody from the class answer. Now, Will started with this 0, -3, right? Why did you pick that one, Will?
Just because it was the largest value.
So the largest value. So could we have used some?
That's the smallest value.
Could you have used the other one first?
Yes.
And would we still have ended up at the same place?
Yes.
So you're going to still end up at the same place, no matter which one you use first, if you do it right. And probably, my guess is that no matter who I pick, somebody else will have done it a different way here, and you can corroborate that. Okay, ready to choose names?
Yes.
Okay, endless confident, so endless confident. Oops, we get the open. Here we go. That's going to be Adam or Will. It's going to be Will. it's not on there? Yeah, I think it is. Okay, well, you did this just now. I'm gonna remove you.
Okay.
Consider you done.
So I got it.
Emma. Okay, I thought I had yours. Hang a second.
Did you say something?
Huh?
Did you say something?
Okay, I got Jana's down here.
I'll do it.
No,
So we're gonna go spin again here. Okay, now we got. It's gotta be Kinsey. Gotta be our birthday girl from yesterday, Kinsey. Kinsey, were you complaining that I never called you? Is that what you were doing the other day? I think I remember you complaining about that a little bit. But Kinsey, today is your day. I hope you had a good birthday yesterday.
She did, she got 2 pieces.
What did you notice here, Kinsey? Help us out here.
I got x equals -2, x equals 3, and then I did f of x equals x plus 2, x minus 3.
So you had x plus 2, x minus 3, is that it? Okay.
And then I put it in that thing. And then I put -2 outside, and then put 5, -12, -23, 42, and I brought down the 5, and then -10, -22, 44, 21, -42, 0. And then I did it again. I put 3 on the outside, 5, -22, 21, brought down the 5, 15, -7, -21, 0.
So 5x minus 7, what you got here? Kinsey, is that right? And then you have 5x minus 7 is equal to 0. What's the value of the 0?
X equals 1.4.
1.4 would be 7 over 5 or 1.4. And so this would be our answer here for that. Is that what you got, Kinsey? Okay, questions on that? Sound looks good. Now, Kinsey picked that particular order for us. Is there somebody who used the 3 first?
Well,
You didn't?
I usually just do left and right.
So if you did left from right, you would have done what Kinsey did, right? You could have done that.
I did that as well.
All right, very good. Good work. Okay, let's go to number 27. Okay, this is a different type of exercise set. Here we're given a degree and with zeros, and we're going to find the polynomial function. And we're going to do, we say find polynomial function, we're going to find a polynomial function in standard form. All right? So if we have these as zeros, what are we going to do to find what the function is? Okay, let's go ahead and set this up, our zeros. We have x equals -2. And so how do we get a factor out of x equals -2? So we have x plus 2 is equal to 0, right? So this is going to be, we'll put x plus 2 here. So that should be one of our factors. And then we have also x is equal to 1. So what is our factor going to be here? X minus 1 equals 0. So we put x minus 1. And then we have also x is equal to 4. So that's going to be x minus 4 is equal to 0. So we have x minus 4. Will that give us a function that meets all the conditions? So that would be good. If we just multiplied everything out, we would get standard form and meet the conditions. Okay, I want you to...
Degree for?
Pardon me?
X next to the 2.
Okay, who asked the question about the degree? Okay, very good. That's a good question. Because what that means is that helps us corroborate what we should already know, because we would have x times x times x, which is x to the third power, okay? Which corroborates how many zeros we've been given, right?
So that's all we have to do?
No, not quite, because I said I want it in standard form, but there's something else that people are missing here. What is being missed here?
We have to,
We need to multiply all those together.
Okay, yes, but even before that,
Leading coefficient 2.
leading coefficient of 2. How do we engineer a leading coefficient of 2 out of this?
Divide by half.
Okay, we can divide by half. Okay, Will's trying to be complicated about it, but how about multiplying by 2? Which is the same as dividing by 1/2, right? So Will's trying to professorialize on us a little bit here, right? Okay, and so now if we multiply everything out, we can get this, right? In standard form. And one thing that I've done in this class, that some people like, others don't,
Box.
is this thing here. And so we have like x plus 2 and x minus 1. So you have x squared, 2x, negative x, and negative 2. So for this, we're going to get, you'll see what I'm doing in a minute. Okay, for this, we get x squared and 2x minus x, that's going to be x, and then we have minus 2, and we're going to multiply this by x minus 4. So here we get x cubed, x times x, x squared, x times negative 2, negative 2x, negative 4 times x squared is negative 4x squared, negative 4 times x is negative 4x, and negative 4 times negative 2 is 8. So what we're going to have here is 2 times, we have x cubed, and then we have negative 4x squared plus x squared, so negative 3x squared. And then we have negative 4x, minus 6x. And then plus 8.
So then we distribute?
And then if we distribute out here, we get
2x to the third. 6 minus 6x squared minus 12x plus 16.
That's wrong, 6x squared, right?
Yeah.
Yeah, let me make sure I get 6x squared. Okay, what I want you to do is put this in your calculator and see if that meets the conditions of the right zeros. You can just see in the calculator where that is. Is that working out for us, Jana?
yes.
It is?
Yes.
Okay, good. Thank you, ladies. Okay, so that's good. What I want you to do is 28. And it should take you a couple minutes to do that. And I'll pick on somebody for 28. And we'll probably get through 28 today. So it's like Hercules. Okay, let me spin a wheel here. That's gonna be Hannah Word.
Oh,
All right, now what do we got here?
2 seconds. You may explain it or just say my answer?
Yeah, just, you can tell me your answer.
2x to the third plus 18x squared plus 34x minus 30.
Did you check it in the calculator?
No, I just finished it.
She just finished it. Okay, if somebody could check that in the calculator. But I'm gonna go ahead and take some liberties. And we're running a little bit low on class time. So I'm guessing that what she did was this. And you just distributed all that together, right?
Oh, wait, no, I didn't.
That's the way you did it? So did you make a
I did
mistake?
that, but I added wrong.
Well, she added wrong.
So let me fix it real quick.
Now, I want to tell you something that Chloe did in fifth period. Is Chloe, what she did first, is she distributed first, like this. So she got like 2x plus 2 and then multiplied everything out. So you can do it like that too. That's what Chloe did. So. But it's so easy to make mistakes on this thing.
I got 6x. Okay, it's 2x to the third plus 6x squared minus 26x minus 30. Is that what you got? Yes. Okay.
Is that right?
Yes.
Okay, good work. Good work. Good job. And we're going to just put that as a wrap.
Are we turning these in or are we gonna push it tomorrow?